Okay, so welcome to today's class. Today we'll be looking at chemistry quiz 2. Okay, and then we'll be answering the questions so that we can revise for the exams. Okay, all right. So quiz 2 had 20 multiple choice questions, which are on organic chemistry. So we're going to try to revise all those questions. Okay, all right. So we start from question 1, which is this guy here. So question 1, they're saying, provide the meaning of the term an electron orbital. Okay, provide the meaning of the term an electron orbital. Okay, so by definition, before I even look at the options, an orbital, okay, is a region that has a higher probability, okay, of electrons being there. Okay, so it's just the region which has a higher probability that you are going to find the electrons there. That's what an electron orbital is. So on these given options, okay, we're going to select the answer that best sounds like what I've just said. Okay, so A, they're saying a space where an electron is located. Okay, and then B, they're saying an electron, okay, pathway. So this one is false. The orbital is not a pathway. An energy level of electrons, no. Okay, an atomic space for valence electrons, this is false, because in the orbitals, you're also going to find those electrons that are not valence electrons. Okay, so here the best answer is we're going to pick a space where an electron is located. That's what we call as an electron orbital. So we choose option A. Question 2, provide the meaning of the term valence electron. Okay, so the term valence electron simply means an electron in the outermost energy shell of an atom. Okay, so if you're still going by this model of a grade 12, you have the nucleus somewhere there with the protons and the neutrons, and then we have these electrons there, and then we can also have these electrons there. Okay, so these electrons in the outermost energy shell are what we call as valence electron. Okay, so we're going to pick B as the correct answer. Question 3, they're saying, provide the meaning of the term valence. Okay, provide uh, the meaning of the term valence. So here, there's a confusion. Okay, I hope you clear it today. There's valence, okay, and then there's valence with the Y. So what's the difference between these two? Okay, so valence, okay, with the Y, it refers to the number of bonds. Okay, number of bonds an element can form. That's what we call as the valence with the Y. And then valence, okay, is just the power to combine. Okay, the combining power of an element. That's what we call valence with the E. Okay, so valence with the E is the combining power or power to combine. The valence with the Y is the number of bonds an electron can form. Okay, all right. We go to question 4. State the golden rule in chemistry. Okay, so the golden rule in chemistry is simply about the molecular energy. Okay, so the golden rule states that the molecular energy, okay, should be low for a molecule to be stable. Okay, the molecular energy has to be low for a molecule to be stable. So we choose C there as the best answer. The lower the molecular energy, the more stable the molecule is. Okay, it's just same with us as human beings. Okay, when we are calm, we are not panicking, then we'll be more stable. Okay, but when we are panicking, or for example, you are writing an exam, okay, you are writing an exam, and then they say maybe 5 minutes remaining and you have not answered most of the question, then you start panicking. So when you start panicking, you are not stable. So meaning that your energy inside you has increased, right? Okay, but when you are calm, it means you have lower molecular energy inside you, so you'll be stable. Okay, so that's the golden rule in chemistry. You can also apply it in real life. Okay, so always be calm. Never be panic, or never be in a panic mode, because you end up making wrong decisions. Okay, so always be calm as you're doing everything. So as you are preparing for the exam, just make sure you are calm, revise the quizzes, revise the tests, revise the notes, the tour sheet, then you're good to go. No need to panic. Okay, so use the golden rule in chemistry. And then question number 5, they're saying, given the empirical formula for the molecule shown, okay, is it, oh, they're saying give the empirical formula for the molecule shown below. So this is the molecule here, and then they want us to give the empirical formula. Okay, so here there are some atoms that have been hidden. So at the end here, there's a carbon double bonded to another carbon, which is bonded to a carbon, bonded to a carbon, and then double bonded to a carbon. Okay, so at each of these carbons, we are going to add hydrogens such that each carbon has 4 bonds. Okay, so this one has 1 there, this one has 2, this one has 2 like that, and then this one will have 1 like that. Okay, so making sure that each carbon has four bonds attached to it. Okay, so let's count the number of carbons. 1, 2, 3, 4, 5. So I'll say C5. Then the hydrogens are 2, 3, 4, 5, 6, 7, 8. Okay, so there are 8 carbons there. Okay, so I'm going to write H8. So that is the empirical formula there. Okay, so just make sure that each carbon there is bonded to 4 bonds. So like this one here, there's 1, 2, and then 3, 4. Okay, even this one here, there's 1, 2, 3, 4. Okay, so that is the empirical formula for that structure. Question 6, they're saying, what is an ionic bond in chemistry? Okay, so an ionic bond, okay, is not a bond between a metal and a non-metal, no. Okay, it's a shortest distance between two, okay. It's a shortest distance between two positively charged ions. Okay. This one sounds wrong. Two, okay. Oh, okay. Yeah, so I read this word here as positively. Okay. I read this word as positively. But no, it's oppositely. So that's the correct definition of an ionic bond. So an ionic bond in chemistry is simply the shortest distance, okay, between two oppositely charged ions. Meaning, for example, if I have sodium chloride here, the sodium will have a positive charge there, okay, and then the chlorine will have a negative charge. So the shortest distance between these two things here is what we call as an ionic bond. Okay. All right. And then question 7, they're saying, what is the meaning of orbital hybridization as used in chemistry? Okay, so hybridization is just the mixing of orbitals to form new ones. So you come here and you select C. Okay, so for example, if I have this S orbital and then I have this P orbital here, these two orbitals can combine to form the sp orbital. So it will be O, and then you have a part of the p orbital like that. So this is the sp orbital. So they mix, okay, to form new ones. So that's the definition of hybridization. The mixing of orbitals to form new ones. Okay. And then question 8, they're saying provide the meaning of the term electronegativity. Okay, provide the meaning of the term electronegativity. Okay, so in general, if I don't look at these options, electronegativity, okay, it's just the tendency, okay, or the power of an atom to attract shared electrons. Okay, that's what electronegativity is. So, for example, if I write a water molecule here, okay, we know that oxygen there is more electronegative than the hydrogen, right? So in this bond here, there are 2 electrons that are being shared between this oxygen and this hydrogen, okay? So the power of this oxygen here to attract these shared electrons to itself is what we are calling as electronegativity. Okay, so when I go on the options, the first one, they're saying ionization potential of a molecule. We're going to say no. Electron affinity, no. The electron attraction, okay, between atoms in a molecule, okay, and then D, they're saying electron movement in a molecule, okay, towards one atom or a group of atoms. Okay, so between these two here, we must find the best answer. So remember I said electronegativity is the tendency or the power of an atom to attract shared electrons. Okay, to attract shared electrons. So meaning the electrons are not moving. Okay, they are not moving, the electrons. So this one here that says electron movement, no, the electron does not move. Okay, it's just attracted by the other atom. So the best answer here is that electronegativity, okay, is the electron attraction between atoms in a molecule like that. Okay, so we choose that one. And then question number 9, the term bond strength is defined as, okay, so the bond strength is just the amount of energy given out or absorbed when forming or breaking bonds. That's what you call as the bond strength. Okay, question 10, the sp3 hybridization of orbitals is associated with which bonds? Okay, so we know that sp3 is associated with single bonds. Okay, and then when you talk to sp2, that one will be associated with double bonds. Then if you're talking about sp, that one will be associated with what? Triple bonds. Okay, so there we just pick the best option, which is the single bond. Question number 11, they're saying, what geometric shape has sp3 hybridized nitrogen? Okay, so if nitrogen is sp3 hybridized, then it is connected to what? 4 items. So these items, they can be bonds, okay, or they can be lone pairs. So if this is my nitrogen here, so they're saying it's sp3 hybridized. So now remember, this nitrogen has 5 valence electrons. Okay, so one of the electron will bond, for example, if you're talking about ammonia, it will bond with a hydrogen. The other one will bond with a hydrogen. The other one will bond with a hydrogen. So you are going to remain with a lone pair on top like that. Okay, so how many atoms are connected to this nitrogen? We have 1, 2, 3, and 4. Okay, so since there are 4 items connected to this nitrogen, okay, it is being referred to as sp3 hybridized. Okay, so now what is the shape of this guy? Okay, so without the lone pair here, the shape would have been tetrahedral. If these bonds, if these electrons were also in a bond, it would be called tetrahedral. But because this is a lone pair here, okay, it will, uh, it will, it will not form tetrahedral geometric shape. Okay, instead it will form what we call as uh, pyramidal. Okay, triagonal pyramidal. That's what it's going to form. Okay, so here we're going to pick D as the best answer. Okay, to form triagonal pyramidal. But here they just put the sign name. Okay, so that's what we have there. Question 12, they're saying, what is the magnitude of the tetrahedral angle? Okay, so the magnitude we all know is 109.5 degrees. That's for a tetrahedral. Okay, so a tetrahedral, you're going to have 109.5 degrees. Question 13, they're saying there are 3 ways of writing and drawing molecular structures. Which one of these 3 is not favored? Okay, so we have the Kekule structure method. So the Kekule is the one where you use lines to show bonds. For example, in water, it will be shown like this. And then the empirical is where you write the formula. So for water, it's just going to be H2O. And then Lewis is where you show the dot as the bonding electrons and as well as those that are not bonding. So for the water, it's going to be bonding bonding. Okay, and then you have these lone pairs like that. Okay, so this is the Lewis, this is the empirical, this is the Kekule. So which one is not favored? The one that is not favored is this one here, because it doesn't tell us anything about the structure. Okay, it doesn't tell us anything about the structure, just tells us the composition. So question 14 now, what type of compounds are saturated hydrocarbons? Okay, so we know that saturated hydrocarbons are what we call alkanes. So what does this mean? It means that they contain single bonds only. Okay, they contain single bonds only. So these single bonds, they can be carbon to carbon or carbon to what? To H. That's what we call as the saturated hydrocarbons. So these alkanes are also called as paraffins. Okay, so now paraffin uh, comes from a Greek word known as param, okay, and affins. So this param here simply means little, okay, and then this one affins means affinity. So in other words, okay, paraffin means little affinity. So meaning poor affinity, okay, or poor reaction. That's what they mean. So because the structures of these alkanes, okay, they will be so compacted together like this with the single bonds, okay, it will leave no room for reaction because everything there is bonded, okay? So there's no room for reaction in a what? In an alkane or a saturated hydrocarbon, which is also known as paraffin. So if I come to my options here now, they're saying what type of compounds are saturated hydrocarbons? So they are compounds of poor affinity, little affinity, okay, or no reactivity. That's what we call these what? Saturated hydrocarbons. Okay, so we choose A as the best answer there. Question 15, they're saying, what is common between the nitrogen atom in ammonia, this guy, and the phosphorus atom in phosphine? So the nitrogen atom in ammonia, I had drawn this earlier. It has a lone pair somewhere there. Okay, and then if I write phosphine, it will have a similar, uh, picture like this. Okay, and then we have those lone pair. So we see that both this guy and this guy, okay, are attached to 4 items. So if they're attached to 4 items, then they are both sp3 hybridized. Okay, so based on this diagram that I've drawn here, we're going to say the answer is sp3. They are both sp3 hybridized, okay? But in actual sense, like in practice, in real life, this phosphide guy here, okay, the phosphorus in phosphine does not undergo any hybridization, okay? Why? Because when it starts to combine with these orbitals from the hydrogen, it uses its pure p orbitals to combine, okay? It uses its pure p orbitals to combine, so there's no hybridization there. Okay, so in real life, this phosphorus does not undergo any hybridization. But according to this diagram that I did, and this since they are saying what is common, so we are looking for the similarities between these two. So both of them, we're going to say, since they're attached to 4 items, they are sp3 hybridized. Okay, and then question 16, they're saying define the term nomenclature as it is used in organic chemistry. So nomenclature is, we all know, it's just a system of naming organic compound. So there are series of rules that you have to follow. Okay, you identify the longest carbon chain, then you number it, you identify if that chain has any substrate, and then you combine them together. So it's a whole lot of system of naming what? Organic compounds. That's what we call as the nomenclature. Okay, all right. And then we move to question 17. How many, okay, are the major or most important bonds commonly encountered in organic chemistry? Okay, so we have the covalent bonds, we have the hydrogen bonds, Okay, then we have the ionic bonds. Okay, so there are just three of them. So we pick three there, the best answer. Question 18, how many sigma bonds are present here? So sigma bonds are present in any bond that you can see. Okay, so there's one sigma bond in any bond that you can see. So we know that bonds in organic chemistry are represented by a line like this, or double or triple. Okay, so in all these here, there's one sigma bond. So here we're just going to count one there, two there, three there, four there, and then five there. But here on the options, there's no answer there. Okay, but there are five sigma bonds. Okay, there are five sigma bonds there. Okay, let's look at question number 19, where they're saying, provide the meaning of the term quantum jump. Okay, so I'll draw something here. I'll say this is the nucleus. So it has protons and neutrons, and then here, these are electrons, like that. Okay, so this is more about atomic structure than organic chemistry. So they're saying, what is the meaning of the quantum jump? So the quantum jump is just when, for example, this electron here in the lower energy level has jumped and that has gone to a higher energy level like that. Or an electron in the higher energy level has reduced in energy and has come there. That's what we call the quantum jump. Okay, so it's the movement from one atomic orbital to a higher or a lower one. Okay, so here we're just going to select a movement of an electron from an orbital to a higher or lower one. Okay, we look at the last question in this quiz. They're saying one of the bonds in organic chemistry is called the pi bond. State how this is formed in an organic reaction. Okay, it is bi. So remember, we have the sigma bond represented by this symbol. Then we have this pi bond, right? So the sigma bond forms by head-to-head overlap. And then the pi bonds forms by side-to-side overlap. Okay, so now we're going to consider two orbitals, the s and then the p. Okay, so when the s overlaps with itself head-to-head like that, what we form here will be a sigma bond. Okay, when a p bond overlaps head-to-head, I mean p orbital overlaps head-to-head with the s orbital, you also form a sigma bond. Okay, or when two p orbitals overlap head-to-head like this, what you form there is also a sigma bond. And then the pi bond is only formed if there's a side-to-side overlap, okay, of the p orbitals. So this is a p orbital, this is a p orbital. And then when there is an overlap side to side, so let me draw it properly here. So the overlap has to be in this form. Oh, bad at drawing. So there's this bond that has been formed there and there. So that's what we call as the pi bond. Okay, that's what we call as the pi bond. So the pi bond is formed by the p to p sideways overlap. So we're going to select D as the best answer here. Going to select D. All right, so that's all for this video. Okay, so if you'd like to access more past papers on organic chemistry, biochemistry, okay, you are free to register with us. Okay, so you can check out our website, which is discretelearning.com. You're going to find videos today, tutorial sheets, the topic, lessons, as well as videos on past papers. Okay, so if you go on our website, you are going to see something like this. Okay, so you register for this course called chemistry here, and then inside this course, you're going to find the organic chemistry for what? Apex second semester. So you can open it. Okay, and then you see tutorials, lessons, tutorial sheets, past test, and exam papers. So you can access anything that you want there. These past papers, you can go there. You access them as you prepare for your exams. Okay, so thank you so much. Until next time.